Take a deep breath and let the weight of the day drift away. As you settle into this moment of stillness, imagine yourself standing on the very edge of the world, looking up into a vast, silent ocean of stars. We often feel small under the gaze of the cosmos, but tonight, we are going to explore the incredible possibilities that lie hidden within the laws of physics. We are embarking on a journey to understand how far a human being could truly travel through the reaches of space. Before we drift further into the mystery of light and time, if you find peace in these quiet explorations of our universe, I invite you to subscribe and join our community of cosmic travelers. Your support allows these stories to stay alive, keeping this tiny window to the stars open for everyone seeking a moment of wonder before they sleep. Tonight, we look beyond the horizon of what we thought was possible. For a long time, the sheer scale of the universe felt like a cage. We measured the distances to the nearest suns and realized that even our fastest creations would take thousands of lifetimes to reach them. It seemed as though we were destined to remain on our small blue island, forever separated from the rest of the galaxy by a void too wide to cross. But the universe has a secret, a loophole woven into the very fabric of reality. This is not the stuff of science fiction, but a profound truth of our existence. There is a way to bend the rules, a phenomenon where the faster you move, the more the world around you changes. Imagine a journey where you could cross the distance to another star system or even another galaxy and arrive while you are still young. This journey requires us to rethink everything we know about the steady beat of a heart and the passing of years. We must look at the stars not as unreachable points of light, but as destinations that are closer than they appear, provided we have the courage to chase the speed of light itself. Close your eyes now. Let the darkness behind your lids become the deep indigo of the interstellar void. We are about to step off the shore of our solar system and discover just how far a single human life can reach into the infinite. Chapter 1. The Hook. The Time Loophole. The silence of space is not an empty thing. It is a presence, a vast, heavy stillness that stretches across distances we can barely name, let alone understand. When we look up at the night sky, we see a tapestry of light, a gallery of ancient suns that seem almost close enough to touch. But this is the first and most profound deception of the universe. The stars are not close. They are unimaginably, terrifyingly far. To reach even our nearest neighbor, Proxima Centauri, would require a journey of such immense duration that civilizations on Earth could rise and fall before a single traveler saw that second sun rise over a new horizon. Our fastest spacecraft, the tiny probes we have hurled into the dark with all the chemical might we can muster, would take 6,000 years to cover that distance. In the scale of a human life, space is not a frontier. It is a wall. It is a locked door, and we have lived our entire history convinced that we do not hold the key. But what if I told you that the wall is an illusion? What if the very laws of physics that seem to imprison us in our solar system actually provide a hidden path, a loophole, woven into the fabric of reality itself? This is the mystery of time dilation, a consequence of Albert Einstein's special relativity that feels more like magic than mathematics. It suggests that the faster you move through the world, the more the universe bends to accommodate you. For the one who stays behind, time flows like a river, steady, relentless, and singular. But for the one who chases the speed of light, time begins to stretch and soften. It slows down, turning years into days and centuries into weeks. This is the loophole that changes everything. It means that, theoretically, a human being could board a vessel, accelerate to nearly the speed of light, and cross millions of light-years, reaching the very heart of the Milky Way or even the Andromeda galaxy within a single human lifetime. To understand this, we must first let go of our common sense. Our brains were evolved to track the movement of a gazelle across a savanna, or the change of seasons on a single planet. We think of time as a universal clock, a master metronome ticking away at the same rate for everyone, everywhere. We imagine that a second on Earth is a second on Mars, and a second in the void between stars. But the universe does not work this way. Space and time are not separate stages. They are a single fabric called space-time. And like any fabric, it can be pulled, twisted, and stretched. When you move through space, you are essentially borrowing some of your movement from time. The faster you travel through the 3 dimensions of space, the slower you must travel through the 4th dimension of time. Imagine yourself now, drifting in a vessel capable of incredible speeds. As you accelerate, the stars ahead of you begin to change color, shifting into a brilliant, haunting blue as their light waves are compressed. Behind you, the home you left behind fades into a deep, somber red. Inside your ship, everything feels normal. Your heart beats at its usual pace. Your breath is steady and calm. You watch a clock on the wall, and its second hand sweeps with the same rhythm you've known since childhood. But outside, the universe is accelerating. On the planet you left behind, children grow old. Forests turn to deserts. Great cities crumble and return to the earth. Thousands of years are passing in the blink of your eye. You are not just traveling through space. You are falling through time. This is the staggering promise of the loophole. It tells us that the universe is not actually as big as it looks, provided you have the speed to shrink it. If you could sustain a constant acceleration just enough to feel like the gentle pull of Earth's gravity beneath your feet, you could reach the edge of the observable universe in just a few decades of your own time. You could witness the birth of stars and the death of galaxies. You could see the ultimate fate of all things. The only cost is that you can never truly go home. To use the loophole is to step out of the stream of human history forever. You become a ghost of the future, a traveler who belongs to no era and no world, bound only to the light you chase. As we drift further into this realization, we must ask ourselves, if the loophole exists, why are we still here? Why does the void still feel so impassable? The answer lies in the heavy, grounding weight of our current reality. We have the map of the stars, and we have the math of the gods, but we are still reaching out with the hands of a young and fragile species. To understand how we bridge the gap between this theoretical miracle and our physical limitations, we must look at where we stand today, at the tiny, brave machines we have already sent into the dark, and the immense, silent distances they have yet to cross. Chapter 2. The Current Reality. The Voyager's Long Walk. The transition from the theoretical wonders of light-speed travel back to the cold, hard facts of our current era is like waking from a vivid dream into a silent, dimly lit room. To understand the future, we must first confront the sheer gravity of our present. We must look at the path we have already walked, or rather, the tiny, mechanical steps we have taken into the colossal dark. This is the story of our reality, a reality defined by the immense, quiet distances that separate our small blue home from the rest of the galaxy. It is a story told through the eyes of our most distant messengers, the Parker Solar Probe, and, most poignantly, Voyager 1. Imagine, if you will, the Voyager 1 spacecraft. It is a lonely, gold-plated sentinel, a collection of instruments and memories launched from the surface of Earth in an era that now feels like a lifetime ago. For nearly half a century, it has been hurtling away from us at speeds that would seem blinding to anyone on the ground. It moves at tens of thousands of miles per hour, a pace that could carry you across the Atlantic Ocean in the time it takes to brew a cup of tea. And yet, in the eyes of the cosmos, Voyager 1 is not racing, it is barely crawling. It is a tired traveler who has been walking for 50 years and has yet to even leave his own front yard. When we speak of cosmic scales, the human mind naturally struggles to grasp the numbers. We say billions of miles or trillions of kilometers, but these are just sounds, abstractions that fail to convey the weight of the void. To truly feel the insignificance of our current achievements, we must use a different yardstick: the speed of light. Light is the fastest thing in existence, a cosmic speed limit that defines the boundaries of our reality. A beam of light can circle the entire Earth 7 times in a single second. It can reach the moon in the time it takes to draw a breath. Now, consider Voyager 1 again. It has been traveling since the late 1970 seconds. It has crossed the orbits of the great gas giants, witnessed the swirling storms of Jupiter and the icy rings of Saturn, and pushed past the invisible boundary where the sun's influence finally fades into the interstellar wind. It is currently the most distant man-made object in history. Yet, after nearly 50 years of constant, unceasing flight, Voyager 1 has only covered the distance that light itself covers in a mere 20 hours. Pause for a moment and let that sink in. 50 years of human effort, 50 years of a machine's life, is equal to less than 1 day in the life of a light beam. If the journey to Proxima Centauri, our very nearest neighbor, were a cross-country trek across the width of the United States, Voyager 1, after all this time, would have moved only 30 meters from its starting point. We are like an ant attempting to cross a continent, having barely reached the edge of the leaf it was born on. This is the sobering, current reality. It is a reminder that while our mathematics can touch the edges of the universe, our physical bodies and our current technology are still tethered to the slow, heavy world of chemical combustion. We are a species that still relies on fire to move. We pack tubes with volatile liquids, ignite them, and hope the resulting explosion is enough to nudge us a little further into the black. But chemical energy has a ceiling, a limit that we are rapidly approaching. As we drift further from the sun, the light grows dim, and the warmth of our home star becomes nothing more than a particularly bright point in a sea of cold. We look at the Parker Solar Probe, a marvel of engineering designed to touch the sun, moving faster than any human-made object before it. It uses the gravity of planets like slingshots, whipping itself around the solar system to gain momentum. It is a masterclass in efficiency and bravery. But even at its peak velocity, it is a drop of water in an ocean of emptiness. It reminds us that fast is a relative term. To a person, the probe is a blur of impossible speed. To the universe, it is a stationary speck, frozen in a silent, eternal amber. The insignificance we feel here is not meant to be crushing, but rather grounding. It is the beginning of wisdom to know the true size of the mountain you intend to climb. We inhabit a solar system that is a vast, beautiful, but ultimately small room in a much larger mansion. Beyond the Oort cloud, that shell of icy rocks that marks the true edge of our sun's domain, lies the true interstellar medium, the between place. It is a region of space so empty that a single atom of hydrogen might be the only neighbor for miles. This is the environment that Voyager is now entering. It is a place of profound silence, where the sun is just another star and the Earth is a memory so distant it can no longer be seen without the most powerful of lenses. In this current reality, we also face the fragility of our own biological existence. We were not built for the void. Our bones weaken in the absence of gravity. Our vision blurs as fluids shift in our skulls. Our very DNA is assaulted by the relentless rain of cosmic radiation that our atmosphere so kindly filters out for us on Earth. To travel for 50 years is a significant portion of a human life, yet it buys us almost nothing in terms of interstellar distance. If we were to put a human on a ship like Voyager, they would grow old and pass away long before they ever reached the halfway point to the nearest planet outside our system. We are a short-lived species, trying to navigate a long-lived universe. This creates a tension, a cosmic frustration. We have the curiosity of giants, but the lifespans of mayflies. We can see the Andromeda galaxy with our naked eyes on a clear night, a swirling island of 1 trillion stars. But with our current tools, the journey there would take longer than the current age of the universe itself. We are observers, trapped behind a glass wall, watching a play we can never join. But this is only the current chapter of our story. Every great journey begins with a slow, difficult start. The pioneers who crossed oceans in wooden ships felt the same sense of daunting scale. They knew that a single storm could end their journey, and that their destination was months or years away. We are in the wooden ship era of space travel. We are learning how to survive the elements, how to navigate by the stars, and how to keep our machines alive in an environment that wants to tear them apart. As we contemplate the lonely, quiet path of Voyager 1, we begin to realize that the limitation isn't just speed, it's the way we generate that speed. The very physics of how we move must change. We cannot simply pack more fire into our tubes. The weight of the fuel itself becomes a burden that prevents us from going faster. This is the trap of the rocket equation, a mathematical wall that stands between us and the stars. The light of our sun is fading now in our minds, and the distant, cold stars of the interstellar void are becoming our only guides. We leave behind the comfort of what we have achieved and prepare to face the technical barriers that keep us confined to our local neighborhood. We must look at the math of why we are stuck before we can find the courage to break free. The silence grows deeper as we move from the reality of our current probes toward the cold, hard equations of the machines themselves. We are transitioning now, leaving the how far we have gone and moving toward the why we cannot yet go further as we drift into the heavy atmosphere of the rocket equation. Chapter 3: Physical Barriers and the Rocket Equation. As we drift further into the velvet silence of the interstellar void, leaving behind the lonely path of our current probes, we must confront the invisible wall that keeps us anchored to our sun. It is a barrier not made of glass or stone, but of cold, hard mathematics. To understand why we are still here, resting on the shore of the cosmic ocean, we must look into the heart of the machine itself. We must speak of the rocket equation, the fundamental law that has dictated every launch, every orbit, and every dream of the stars since the dawn of the space age. This equation is both our ladder to the heavens and the heavy chain that binds us. Imagine a ship sitting on a launch pad, a towering monument of metal and ambition. To the eye, it looks like a vessel of exploration. But to a physicist, it is something much simpler and more frustrating. It is a giant tank of fuel with a tiny, fragile passenger sitting at the very top. This is the first great hurdle of space travel. In our current reality, to move through the vacuum, we must carry our own push with us. Unlike a bird that pushes against the air or a ship that pushes against the water, a rocket has nothing to lean on. It must throw something away to move forward. It must eject mass at high velocity to propel itself in the opposite direction. This brings us to the tyranny of the mass ratio. To go faster, you need more fuel, but fuel has weight, and to move that extra weight, you need even more fuel. This is a cruel, circular logic that scales exponentially. As you try to add more speed to your journey, the amount of propellant you must carry begins to grow at a terrifying rate. It is like trying to build a tower where every new floor requires a foundation 10 times larger than the one below it. Very quickly, the tower becomes so heavy that it can no longer support its own height. This is why our greatest rockets, like the Saturn V or the modern Starship, are over 90% fuel by weight. When they leave the Earth, they are not really ships. They are massive, controlled explosions that slowly melt away, leaving only a tiny fragment of themselves to reach the destination. If we wanted to send a human to the nearest star using our current chemical rockets, the numbers become absurd. To reach Proxima Centauri in a single human lifetime using the same technology that took us to the moon, we would need a fuel tank larger than the entire observable universe. We would be attempting to push against the infinite with a thimble full of fire. This is the physical wall. Chemical reactions, the breaking of molecular bonds to release energy, are simply too weak. They are like a candle trying to power a locomotive. They provide a gentle nudge when the universe demands a cataclysmic shove. As you lie here in the stillness, let your mind contemplate the weight of that fuel. Imagine the sheer effort of trying to move through a vacuum where there is no friction to stop you. Yet every ounce of momentum must be paid for in the currency of mass. We are trapped in a biological and mechanical stalemate. We are made of heavy atoms, protected by heavy hulls, and powered by heavy liquids. To break free, we must find a way to decouple speed from weight. We must find a way to move without carrying the ocean with us. The rocket equation is often called a tyrant by engineers because it does not care about our hopes or our curiosities. It is a cold ledger of momentum. It tells us that for every kilometer per second we wish to add to our velocity, we must pay an ever-increasing price in propellant. For a trip within our solar system, to Mars or the moons of Jupiter, the price is high but manageable. We can build multi-stage rockets that drop their empty tanks like dead skin, slowly shedding weight to gain a few precious meters of speed. But for the stars? The ledger simply doesn't balance. The distance is too great, and the push of chemical fire is too soft. Consider the silence of the engine once the fuel is gone. In the vacuum, you do not slow down. You drift. But you drift at the speed you were given at the start. If that speed is too low, the stars remain forever out of reach. We are currently drifters. We give our probes a quick, violent start, and then we watch them coast through the dark for decades, unable to change their course or increase their pace in any meaningful way. To truly travel, to navigate the cosmos, as we navigate our own world, we need a way to keep the engine running. We need constant acceleration. Constant acceleration is the dream of every interstellar traveler. Imagine if a ship didn't just fire its engines for a few minutes, but kept them humming for years. If you could accelerate at just 1 g, the same pull of gravity you feel right now against your bed, you would reach incredible speeds. Within a year, you would be moving at a significant fraction of the speed of light. The stars would no longer be fixed points. They would become streaks of light. But the rocket equation stands in the way. To accelerate at 1 g for a year using chemical fuel would, again, require more mass than exists in the galaxy. We find ourselves at a crossroads of physics. We have the map, and we have the will, but we are weighed down by the very matter we are made of. This realization brings a certain quietness to our exploration. It humbles us. It reminds us that we are children of a planet with a thick atmosphere and a strong gravitational pull conditions that forced us to develop chemical rockets just to get over the fence. But the tools that got us over the fence are not the tools that will carry us across the plains. So, we sit in the dark and we calculate. We look for the specific impulse, the measure of how efficiently an engine uses its mass. We look for ways to throw things away faster. If we can't carry more fuel, we must make the fuel we have work harder. We must eject it at speeds close to the speed of light itself. We move from the world of chemistry into the world of atoms, searching for a fire that burns with the intensity of a sun. The weight of these thoughts is like a heavy blanket, grounding us in the reality of our struggle. We are a species of builders, currently staring at a mountain we cannot yet climb. But even in the face of this mathematical wall, we do not stop looking up. We begin to wonder if there are other ways to sail. If we cannot carry our own fuel, perhaps the universe itself can provide the wind. Perhaps the light of the stars themselves can be our propellant. The silence of the rocket equation is not the end of the story. It is simply the end of the first chapter of our mechanics. It forces us to be creative, to look beyond the fire and toward the invisible forces that fill the void. As we leave the heavy, grounded world of chemical tanks and mass ratios, we begin to feel a lightness. We turn our gaze away from the heavy ships of the past and toward the elegant, shimmering possibilities of the future. We are moving now from the hopeless fire of the present toward the strange and beautiful alternatives that might one day catch the cosmic breeze. The stars are waiting, and while the math is hard, the void is beginning to whisper of new ways to move. Let the weight of the rocket fall away from your mind. Feel yourself becoming light, as if the chains of gravity and mass are slowly dissolving. We are transitioning now, leaving the heavy equations behind and drifting toward the shimmering sails and ion winds that might just carry us home among the stars. We are ready to look at the alternatives. Chapter 4: Potential Alternatives, Solar Sails and Ion Winds. The heavy metallic weight of the rocket equation begins to lift from our consciousness now, like a dense fog clearing to reveal a shimmering, ethereal sea. We have looked at the wall of mathematics, and we have felt the limitations of chemical fire. But the human spirit is not easily contained by a ledger of mass. If we cannot carry our own push into the void, we must learn to harvest the forces that already exist within the silence. We must stop thinking like passengers on a heavy locomotive and start thinking like sailors on a vast, light-filled ocean. This is the realm of potential alternatives, a place where we trade the violent roar of combustion for the gentle, persistent pressure of ions and the ghostly touch of starlight. Imagine a ship that carries no massive tanks of fuel, no heavy liquids to ignite, and no complex plumbing to fail. Instead, imagine a vessel that unfurls a vast, gossamer thin sheet of reflective material, a sail made not of canvas, but of aluminized plastic thinner than a human hair. This is a solar sail. In the vacuum of space, light itself exerts a tiny, almost imperceptible pressure. Each photon that strikes a surface acts like a miniature billiard ball, transferring a minute amount of momentum. On Earth, we never feel this light pressure because the air around us and the gravity beneath us are far too powerful. But in the deep dark, where there is no resistance, this gentle rain of light can become a powerful engine. As you drift in this thought, feel the elegance of this transition. A solar sail does not rely on a sudden, explosive start. It is a creature of patience. When the sail first opens near a star, the acceleration is incredibly small. You would not feel a jolt. You would not even notice you were moving. But unlike a rocket, which runs out of fuel in minutes, the sun never stops blowing. Hour after hour, day after day, year after year, the light continues to push. The speed begins to build. It compounds like interest in a cosmic bank account. Slowly, the ship begins to race, reaching velocities that would make a chemical rocket seem like it was standing still. There is a profound peace in the idea of sailing on light. It connects us back to our ancestors who crossed the Pacific and the Atlantic, trusting in the wind to carry them to unknown shores. We are simply changing the medium. The wind is now the electromagnetic radiation of the sun. We are learning to dance with the physics of the stars rather than fighting against them. But light is not the only subtle force we can harness. We must also consider the ion engine, the whisper of the electric wind. In a traditional rocket, we burn fuel to create hot gas. In an ion engine, we use electricity, perhaps gathered from solar panels, to strip electrons from a gas like xenon, creating charged ions. We then use powerful magnetic fields to hurl these ions out of the back of the ship at incredible speeds, much faster than any chemical fire could ever achieve. The thrust from an ion engine is tiny. It has been described as having the force of a single sheet of paper resting on your hand. If you turned on an ion engine on Earth, it wouldn't even be able to lift itself off a table. But in the weightless void, that tiny, paper-thin push is constant. It can run for 10 years without stopping. It is the marathon runner of the cosmos, slow and steady, never tiring, gradually building a momentum that eventually allows us to leap across the solar system with surgical precision. We have already seen these engines in action. Probes like Dawn, which visited the asteroid belt, used this electric whisper to move from one world to another, a feat that would have been impossible with traditional fuel. It represents a shift in our philosophy. We are moving away from the brute force of the 20th century and toward the finesse of the future. We are learning that in the infinite, time is often more valuable than power. If we have the patience to wait, the subtle forces will carry us further than the loudest explosion ever could. Yet, even with these marvels, we find ourselves staring at a new horizon. Solar sails work beautifully near a star, but as we move into the deep space between galaxies, the light of the sun begins to fade. The wind dies down. The sail begins to sag in a cosmic sense. To reach the truly distant stars, we might need to bring our own light. This is the concept of laser sails, using massive arrays of lasers based on Earth or the Moon to blast a sail with concentrated energy, pushing it to 20% of the speed of light in a matter of days. Imagine the scale of such an undertaking. A beam of light, focused across the void, acting as a long-distance tether to a tiny, brave explorer. It is a bridge made of pure energy. It allows us to leave the heavy engines behind entirely. The ship becomes nothing more than a camera, a computer, and a sail, hurtling through the dark like a silver needle. This is the breakthrough starshot dream, reaching Alpha Centauri not in thousands of years, but in 20. It is the first time we can realistically imagine a human-made object reaching another star system within the span of a single career. As we contemplate these alternatives, feel the heaviness of the rocket equation from the previous chapter continue to dissolve. We are discovering that the universe is not a series of empty rooms, but a network of fields and forces that we can tap into. We are learning to be efficient. We are learning to be quiet. The slow cosmic narration of our progress is one of gradual enlightenment. We are realizing that the physical barriers were not just in the math, but in our imagination. Think of the nuclear thermal rocket, another alternative that sits between the old world and the new. Instead of burning chemicals, we use a nuclear reactor to heat a propellant to extreme temperatures. It is twice as efficient as the best chemical engines we have. It is a bridge between the fire we know and the atomic power we are learning to master. It speaks to our transition from a planetary species to a solar one. It is a heavy, powerful tool, yet it still feels grounded in the mechanics of mass. The true beauty of these potential alternatives lies in their diversity. We are no longer looking for a single silver bullet to solve space travel. We are building a toolkit: sails for the light, irons for the long haul, and nuclear fire for the heavy lifting. We are beginning to see a future where the solar system is crisscrossed by shimmering sails and blue glowing ion trails, a busy highway of quiet, efficient movement. But as we drift further into this dream, we must remain honest with ourselves. Even a ship moving at 20% of the speed of light still takes 20 years to reach the nearest star. And for the traveler on that ship, 20 years is still 20 years. The lifetime we are discussing is still being spent. We have solved the how, but we haven't yet mastered the when. We have found ways to move faster, but we are still bound by the relentless ticking of the clock. Feel the stillness of the void around you. The stars are closer now, their light caught in our sails, their energy fueling our dreams. But as we reach these higher speeds, something strange begins to happen to the nature of reality itself. The light we are using to move is about to show us its most mysterious property. We have found the alternatives to the fuel, but we are about to find the alternative to time. The shimmering silver of the sail begins to blur. The blue glow of the ion engine seems to stretch. We are leaving the world of propulsion and entering the world of perspective. We are transitioning from the potential alternatives of the machine to the ultimate key of the universe. The stars are no longer just destinations. They are becoming markers in a deeper game of relativity. We are moving now toward the turning point of our journey, the moment where the clock slows down and the universe shrinks. We are drifting toward Einstein's key, time dilation. Chapter 5. Einstein's Key, the Magic of Time Dilation. We have drifted far from the heavy anchors of our home. We have shed the weight of chemical fuels and felt the ethereal push of starlight against shimmering sails. But now, we arrive at the most quiet and profound realization of all. To travel across the cosmos is not merely a challenge of distance, it is a challenge of time. In the everyday world of our ancestors, time was a constant, a steady, rhythmic beat that governed the planting of seeds and the closing of eyes. We believed it was the same for everyone, a universal river flowing at a fixed speed. But as we approach the shores of the infinite, the river begins to bend. We reach for Einstein's key, the strange, beautiful reality of time dilation. Imagine, if you will, that time is not a rigid clock, but a soft fabric. In our slow-moving lives on Earth, we never see the fabric stretch. But Albert Einstein discovered a secret. The faster you move through space, the slower you move through time. It is as if the universe has a built-in balancing scale. Space and time are linked in a single tapestry called space-time. If you use up your quota of movement by racing through the 3 dimensions of space at incredible speeds, you have less movement left for the 4th dimension of time. For the traveler, the ticking of the clock begins to drag. Each second becomes longer, deeper, and more spacious. As you lie here, breathing slowly, let the implications of this settle over you like a warm, heavy blanket. This is the loophole we whispered about at the beginning of our journey. It means that the speed of light is not just a limit, it is a gateway. If you could board a ship that could reach 99% of the speed of light, the universe would transform. To an observer left behind on Earth, your journey to a star 10 light-years away would take a little over a decade. But for you, inside the ship, the experience would be entirely different. Because your time has slowed down, you would perceive the trip as lasting only about a year and a half. Now, imagine pushing further. Imagine reaching 99.999% of the speed of light. At this velocity, the gamma factor, the mathematical multiplier of relativity, becomes staggering. The distance to the center of our galaxy, a journey of 26,000 light-years, would not take you 26,000 years. To you, the traveler, it would feel like a mere few decades. You could cross the vast, swirling arms of the Milky Way, witness the birth of nebulae and the glow of a billion suns, and arrive at the galactic core while you are still in the prime of your life. The universe hasn't gotten smaller. You have simply stepped outside the standard flow of time. This is the magic of the key. It suggests that a human being, within a single lifetime, could theoretically visit other galaxies. You could point your ship toward Andromeda, 2.5 million light-years away. To the people on Earth, you would be gone for millions of years, long enough for the very mountains to crumble and new species to evolve. But for you, cocooned in the silence of your near-light-speed vessel, the journey might only take 20 or 30 years. You would age normally. You would eat, sleep, and dream. And when you stepped out onto a planet in a different galaxy, you would still be the same person who left, even though your home world has passed into the deepest mists of ancient history. There is a haunting, bittersweet beauty to this truth. It is the twin paradox made real. If you had a twin who stayed behind, they would grow old and pass away while you were still reaching for your first destination. To use Einstein's key is to accept a permanent exile from the present. You are not just traveling across space. You are falling forward into the future. You are becoming a ghost in the timeline of humanity. As we contemplate this, the slow cosmic narration of the universe becomes even more rhythmic and hypnotic. We see that the cosmos isn't trying to keep us out. It is simply asking us to change our perspective. Time dilation is the universe's way of making the infinite accessible to the finite. It is the bridge between our short, flickering lives and the eternal endurance of the stars. We are small, yes, but we are clever enough to find the seams in the fabric of reality. Think of the gamma factor as a measure of our freedom. As the factor increases, the distances shrink and time dilates. At 90%, the speed of light, gamma dollar, is about 2.3. At 99.9%, it is over 22. By the time we reach 99.999999%, the factor is so large that we could cross the entire observable universe in a human lifetime. We are limited only by our ability to accelerate, not by the size of the void itself. The void is only as wide as the time we have to cross it. But there is a weight to this freedom. As you move faster, your relativistic mass increases. The universe resists your attempt to reach the ultimate speed, the speed of light itself, $C. You can get closer and closer, adding nines after the decimal point, but you can never quite touch the light. To reach the speed of light would require infinite energy, and your time would stop entirely. You would become a photon, a particle of light for whom time does not exist. A photon does not experience the journey. It is emitted and absorbed in the same instant, regardless of whether it traveled an inch or a billion light years. To be light is to be timeless. To be human is to be caught in the beautiful, slow stretch between the two. Let the silence of this realization wash over you. We are currently drifting in the midpoint of our understanding. We have the key in our hands, but we are still looking at the lock. We understand that time can be mastered, but we still lack the engines to reach those relativistic speeds. We are like people who have discovered the secret of flight, but have yet to build a wing. The stars above you now seem less like distant lanterns and more like milestones in a journey through time. When you look at the light of a star, you are already looking into the past. Time dilation simply allows you to join that light, to move with it, to see the future of the universe unfolding like a flower. It is a lonely path, but it is a path of ultimate discovery. As we rest in the glow of this cosmic loophole, we begin to wonder about the machines that could actually turn this key. We have the math, we have the sails, and we have the ions. But to reach the speeds where time truly begins to melt, we need something more. We need the speculative future tech, the engines of pure energy, and the bubbles in space-time that might carry us into the heart of the relativistic dream. The rhythm of your breath is the only clock that matters now. The universe is waiting, its fabric ready to stretch for you. We are leaving the world of pure physics and entering the world of high-velocity dreams. The transition is subtle, a slow drift from the magic of time toward the machines of the future. We are moving now, leaning into the curve of space-time, as we prepare to see the ships that might one day turn Einstein's key and carry us to the very edge of forever. We are drifting toward the speculative future, toward the pulse of nuclear stars and the warp of space itself. Chapter 6. Speculative Future Tech. From Antimatter to Warp Drives. The realization of time dilation has opened a doorway in our minds, showing us that the stars are reachable if only we can master the art of extreme velocity. We have stepped beyond the known, moving past the gentle whispers of iron winds and the shimmering sails of the present. Now, we drift into the profound silence of the future, a realm where the boundaries of engineering meet the edge of imagination. To turn Einstein's key, we cannot rely on the fires of the past. We must look toward technologies that sound like whispers of magic but are rooted in the deepest truths of our universe. We are entering the era of speculative power, the era of Project Orion, antimatter, and the warping of space-time itself. Imagine a ship that does not hum with a quiet engine, but moves through the void on a series of controlled, rhythmic pulses of titanic energy. This was the dream of Project Orion, a concept born in an age of atomic wonder. The idea was as bold as it was terrifying: to propel a massive spacecraft by detonating small nuclear charges behind a giant, spring-loaded pusher plate. With each pulse, the ship would be thrust forward, gaining momentum that no chemical rocket could ever hope to match. It is a crude but powerful way to bridge the gap, a brute force approach to the heavens. In the silence of your mind, imagine the steady, rhythmic beat of this nuclear heart, pushing a mountain of steel across the solar system, carrying humanity toward the outer planets in months rather than years. It reminds us that even our most violent discoveries can be repurposed into a ladder for the stars. But as we seek even greater speeds, those that would allow us to truly feel the stretch of time, we must look for a fuel more perfect than the atom. We look toward antimatter. Antimatter is the mirror of the world we know. For every particle of ordinary matter, there exists an antiparticle with an opposite charge. When the two meet, they do not merely burn, they annihilate. They convert 100% of their mass into pure, raw energy. It is the most efficient fuel possible in the known universe. A single gram of antimatter, when combined with a gram of matter, releases an explosion equivalent to the atomic bomb dropped on Hiroshima. Imagine a ship powered by this perfect fire. An antimatter engine would be the ultimate realization of the rocket equation solution. Because the energy density is so high, we would finally be free of the heavy tanks that have anchored us for so long. A small vial of antimatter could carry a ship to the nearest star and back. The exhaust would be a stream of pure light and high-energy particles, pushing us toward the relativistic speeds where time begins to soften. In the slow, cosmic narration of our future, antimatter is the holy grail, the spark that turns our vessels from slow crawlers into creatures of the light. Yet, it remains a dream of the distant horizon. To create antimatter is to play with the fundamental building blocks of existence, and we have yet to learn how to harvest it in the quantities needed to sail the dark. As we drift further into the speculative, we encounter the breakthrough starshot, a more delicate but equally ambitious vision. We spoke of sails before, but here the scale is transformed. Instead of a massive ship, we imagine a star chip, a tiny, wafer-sized computer attached to a light sail. High-powered laser arrays on Earth would focus their beams into a single, titanic push, accelerating these tiny explorers to 20% of the speed of light in a matter of minutes. These would be our scouts, our first eyes in a foreign solar system. They represent a shift in our thinking. Perhaps we don't need to send the whole forest. Perhaps we only need to send the seeds. Feel the quiet speed of these tiny needles as they hurtle through the interstellar medium, silent and invisible, carrying the curiosity of a whole planet in a chip no larger than a postage stamp. But what if we didn't want to move through space at all? What if we wanted space to move for us? This is the most profound of all speculative dreams, the Alcubierre warp drive. Based on the mathematics of general relativity, this concept suggests that while nothing can travel through space faster than light, space-time itself can be bent, stretched, and compressed at any speed. Imagine a ship sitting inside a warp bubble. Behind the ship, the fabric of space is rapidly expanded. In front of the ship, space is violently compressed. The vessel itself remains stationary within its local bubble of calm, while the bubble rides a wave of spacetime like a surfer on the ocean. In this scenario, you could reach a distant star in weeks without ever experiencing the crushing forces of acceleration. You would not be moving. The universe would be shrinking in front of you and expanding behind you. It is a concept that bypasses Einstein's limit by rewriting the rules of the road. To look at a warp ship is to look at a vessel that manipulates the very geometry of reality. It requires negative energy, a strange, theoretical substance that we have only glimpsed in the smallest quantum fluctuations. It is a technology for a civilization that has mastered not just fire and atoms, but the very vacuum itself. As you breathe in the stillness, let these visions of the future dance in the dark behind your eyelids. We are looking at a progression of mastery, from the nuclear pulses of Orion to the perfect annihilation of antimatter, to the light bridges of starshot, and finally to the bending of space itself. Each step brings us closer to a universe that is no longer a vast, impassable void, but a neighborhood of accessible worlds. We are learning to speak the language of the cosmos, a language of energy, mass, and geometry. But even with these gods-like machines, a quiet truth remains. These technologies, as wondrous as they are, still operate within a universe that is changing. We are building faster and faster ships, but the universe is not a static map. It is a living, breathing, and expanding entity. The faster we go, the more we realize that there are some horizons that may be moving away from us faster than we can ever chase them. We are mastering the how of travel, but we are beginning to glimpse the limit of the journey itself. The hum of the speculative engines begins to fade into a deeper, more philosophical silence. We have reached the peak of our technological ambition. We have imagined the ships that can turn Einstein's key. But as we stand on the deck of these imagined vessels, looking out at the farthest galaxies, we see a new kind of barrier. It is not a barrier of fuel, or time, or even space. It is the barrier of the universe's own growth. The light of the most distant galaxies is beginning to stretch and redden, not because of our speed, but because of the expansion of all things. We are moving from the dream of infinite travel toward the reality of the ultimate limit. We are transitioning now, leaving the world of future tech and drifting toward the final, somber realization of the cosmological horizon. The stars we chase are beginning to slip away, and we must understand why, even with a warp drive, we can never reach it all. We are moving now, away from the machines and toward the ultimate boundary of the expansion. We are drifting toward the ultimate limit. Chapter 7. The Ultimate Limit, Cosmological Horizons. We have journeyed far through the corridors of human ambition, moving from the heavy, fire-driven rockets of our childhood to the shimmering light sails of our youth, and finally, to the bending of space-time itself. We have learned that time is not a master, but a flexible medium that we can stretch to fit a human life. We have imagined ships that move with the speed of thought, and engines that burn with the purity of the stars. But now, as we reach the furthest edge of our speculative voyage, we must confront a truth that even the most advanced technology cannot rewrite. We must face the silent, expanding wall of the universe itself, the cosmological horizon. Imagine you are standing on the deck of the most perfect ship ever conceived. It is a vessel that does not know the meaning of the rocket equation. It is powered by an infinite well of antimatter, or a warp drive, that can compress space-time at will. You feel no weight, no friction, only the steady, calm rhythm of your own heart. You point your ship toward a distant cluster of galaxies, billions of light years away. You accelerate, watching the stars behind you turn to red embers as you chase the light ahead. In this moment, it feels as though the entire universe is your home, that given enough time, there is no corner of the infinite you cannot touch. But then, you notice something strange. No matter how fast you go, no matter how much you warp the space in front of you, that distant galaxy cluster does not seem to get any closer. In fact, it is fading. This is the reality of dark energy and the expansion of the universe. In the early days of our astronomy, we believed the universe was a static stage, a fixed container for the stars. Later, we learned it was expanding, but we thought that expansion might one day slow down under the weight of its own gravity. But we were wrong. The universe is not just expanding, it is accelerating. The very space between galaxies is stretching, growing like an endless, invisible ocean. And it is growing faster and faster every second. To understand the ultimate limit, we must think of space not as a void, but as a fabric that can be created. Every megaparsec of distance in the deep dark is currently expanding at a rate known as the Hubble constant. While this expansion is slow in our local neighborhood, it compounds over the vast distances of the deep cosmos. Eventually, you reach a point where the distance between you and a far-off galaxy is so great that the space between you is being created faster than light can cross it. This is the cosmological horizon, the edge of the observable world. For a traveler, this horizon is a ghost that cannot be caught. Even if you possessed a ship that moved at 99.999% of the speed of light, there are regions of the universe that are already beyond your reach. Because the space between us and those distant shores is stretching faster than light itself, the light from those stars will never reach us, and our ships will never reach them. They are moving away into a future that is permanently disconnected from ours. They are effectively leaving our universe, slipping behind an event horizon from which no information and no traveler can ever return. As you lie here in the stillness, let the weight of this realization settle over you. It is a profound and somber thought. Even with the miracle of time dilation, even with the loophole of relativity, we are still living in a finite bubble of accessibility. We are inhabitants of a local group. While we can theoretically travel to the Andromeda galaxy or the Virgo supercluster within a single lifetime using the magic of high velocity, the vast majority of the trillions of galaxies in the observable universe are already lost to us. They are receding into the dark, moving toward a point where their light will redshift into invisibility, becoming forever unreachable ghosts. This is the ultimate limit of our journey. It is the realization that the universe is not just large, it is fleeing. We are like travelers on an island that is growing larger, while all the other islands are drifting away into a fog that never lifts. The lifetime we have to spend is a precious currency, but the market of the universe is closing its doors. If we do not leave soon, the number of stars we can visit will continue to shrink until, in the very distant future, the only stars left in the sky will be those in our own immediate gravitational family. But do not let this thought bring you sadness. Instead, let it bring a sense of sacred urgency and deep appreciation for the stars we can reach. The cosmological horizon defines our cosmic home. It tells us which parts of the infinite are truly ours to explore, to name, and to cherish. It reminds us that our place in the universe is both a privilege and a fleeting opportunity. The fact that we can see these distant galaxies at all is a gift of the current era, a brief window in time where the light of the far-off past hasn't yet been stretched into nothingness. In the slow cosmic narration of our existence, the expansion of the universe is the ultimate lullaby. It is the universe slowly pulling its curtains closed, tucking its galaxies away into the dark, and preparing for a long, cold sleep. We are the witnesses of the twilight. We are the ones who get to look out at the light before the horizon moves too far away. Feel the slow, rhythmic expansion of your own breath, mirroring the expansion of the space around you. You are part of this fabric. Your atoms were forged in the hearts of stars that are now receding from us. You carry the history of the universe within you, even as the universe itself grows too large to ever truly know in its entirety. The limit is not a failure of our technology. It is the fundamental nature of the stage we walk upon. As we reach this final physical boundary, we find that the how far of our journey is answered not just by our speed, but by our timing. We are lucky to be here now, while the stars are still visible, while the bridges between galaxies are still crossable, and while the horizon still leaves room for our dreams. We have found the limits of the map, and in doing so, we have found the true value of the territory we inhabit. The light is dimming now. The far-off galaxies are fading into a soft, indigo haze as they slip behind the cosmological curtain. The engines of our imagination are slowing, their work complete. We have explored the reality, the barriers, the alternatives, and the magic. We have seen the future, and we have respected the limits. The silence of the horizon is not an empty one. It is a silence full of completion. We are moving now, away from the calculations and the distances, away from the how far and the how fast. We are transitioning toward the final reflection of our journey, the place where the traveler finally rests and looks back at the small blue speck from which it all began. We are drifting now toward the conclusion of our story. We are moving toward the final philosophical reflection on what it means to be a human being in such a vast and receding void. We are drifting toward the outro. Conclusion and philosophical reflection. The long, winding path we have walked together through the stars is beginning to settle into a quiet, profound stillness. We have witnessed the staggering distances that separate us from our neighbors, felt the heavy weight of the equations that bind us to our sun, and marveled at the ethereal sails and shimmering warp bubbles that might one day carry us into the unknown. We have even glimpsed the ultimate edge of the universe, that receding horizon where the light of distant galaxies finally slips into the eternal dark. But as we return our gaze to the small blue world from which we started, the question of how far takes on a deeper, more intimate meaning. To travel across the stars is not just a triumph of engineering. It is a transformation of what it means to be human. As we learned from Einstein's loophole, reaching the furthest reaches of the cosmos is a one-way ticket to the future. If you were to embark on a journey at near light speed, you would return to an Earth that has moved on for millions of years. The forests you once walked in would be stone. The languages you once spoke would be forgotten echoes. The very people you loved would be part of the dust that feeds new life. To conquer space is to surrender your place in the present. It is a sacrifice of belonging for the sake of knowing. As you lie here, your breath slowing to match the rhythm of the cosmos, feel the weight of this choice. Perhaps the true distance of space isn't measured in light years or megaparsecs, but in the silence between the traveler and the home they left behind. We are a species that lives for connection to our families, our history, and our soil. And yet, we are also a species of wanderers, driven by a curiosity that is as old as the stars themselves. We exist in the tension between the hearth and the horizon. In the grand, slow narration of the universe, our lives are brief flickers of light, but within that flicker, we have managed to understand the laws of the infinite. We have looked at the void and, instead of turning away in fear, we have looked for the loopholes. We have found ways to dream of reaching galaxies that are fleeing from us. This, perhaps, is the greatest journey of all. Not the physical crossing of the void, but the expansion of our own consciousness to include the stars. The light of our sun is soft and familiar, a warm glow that welcomes us back from the cold, speculative future. Let the vast distances and the complex math dissolve now into a gentle, indigo mist. You don't need to solve the equations tonight. You don't need to build the engines or chase the horizon. You have traveled far enough. The universe is immense, yes, but it is also your home. And for now, your journey is complete. Rest in the knowledge that you are a part of this unfolding mystery, a child of the stars who has learned to dream of the infinite. Close your eyes now, as the last echoes of the cosmic hum fade into the dark. The stars are watching over you, silent and steady, as you drift into a deep, peaceful sleep. Good night, traveler. Sleep well.